My name's Tim. I work at a company called Cubis Systematic Strategies, which is the quantitative systematic trading arm of Point72, which is a hedge fund. And I also teach in the computer science department at Columbia in New York. Full disclosure, this is the link to the slides. I pip installed one thing 30 minutes ago, and everything broke. But I think I got it all working again in the 5 minutes at the front. So if something doesn't work randomly, just be prepared for it. But I'm sure everyone's been in that same place where one dependency changes and the whole world crashes. So this is a talk about high-performance programming for the web. I'm going to try and minimize the amount of JavaScript because nobody likes JavaScript. And try and address some background, some motivation, why we made this library, but also what it's good at. Talk a little bit about the library itself, which is called Perspective. I'll do some live coding and some demos, and hopefully everything goes well. So the background here is, we're all Pythonistas. We have access to a huge number of web frameworks. I listed a very small subset of them here. And obviously, whether or not you're in Python or using JavaScript, for example, you have a ton of data visualization components. But despite all of this abundance, and I'm not trying to speak ill of any libraries, some stuff is still pretty clunky, pretty difficult to do, even with some more complicated, some more advanced of these libraries or components. Some of these pain points are going to be virtualization. So this is my home Airflow setup, which does some stuff. And I hate seeing pages like this, right? So pagination. We're always prone to paginate things. And sometimes that makes a lot of sense, but other times I just want to scroll through the whole grid. I just want infinite scroll. I want the table to be virtualized behind the UI so that I don't want my UI to be loading gigs and gigs of data, but I would like it so that as I scroll, for example, my UI is being smart enough to proactively grab just what's visible on the screen. So a lot of frameworks just can't or won't support unbounded data sizes. So fetching a range of things, a lot of times they just don't support that. Another pain point is dumb grids. So most grids that we use, like tables that we visualize, are dumb. At the best, they might support filtering and sorting. So I might want to say filter this column by some value or sort by this column. Maybe they support Spark charts. So those are little inline charts that you can have in the middle of your table. And maybe, which is a big maybe, they support pivoting. So there are a lot of really great grids out there these days. I went to a talk on great tables recently, which was fantastic. So definitely check that out if you haven't looked at it yet. This is an example of a relatively advanced grid. This is aggregate. So you can see even here, I obviously picked one of their examples from their page. Even here, this is pivoting by country and then sub-pivoting by something. I don't really know. It's kind of hidden here. We see it's pretty sparse grid. We see a lot of visual space is taken up by configuration of things. If this is kind of the advanced grids, you can imagine that this is pretty difficult to configure and still doesn't work that well. And even if you get this is just the grid form, right? What if I want to see the same data pivoted in another form, a heat map or something like that? So this is the other thing that you see a lot of, which is visual overload of just let me present as much data as I possibly can on one page. Usually there's not a ton of meaningful data. This is a classic one like Grafana. And oftentimes we do this because the components that we're using don't let us explore them further. So I present you the grid. It has been pre-configured by me, the developer. You, the end user, might not be able to do anything with it. So again, maybe you can sort a column or something like that. You definitely almost always can't switch between visualizations and stuff like that. And the pain point number 3 is streaming. So all of these different things, the frameworks we talked about, these pain points that I previously mentioned, they all exist for static data, but they also exist for streaming data. So if you're paginating things, how are you going to do with streaming, right? Are you going to do some amount of polling for updates and then repaginate things? It's pretty prone to race conditions. And a lot of visualization frameworks also just don't really make this easy. They expect you to have all your data up front, and if you want new data, you have to re-render them or recall them. So I put an example here of the Fast API WebSocket example server, where they've got some front-end code. It's kind of a lot. And then here's the back-end code, which is also kind of a lot. I love Fast API. My example here is going to use Fast API. But the takeaway here is just that even with what is probably the best web framework we have right now in Python, doing stuff with streaming data is still kind of complicated, still pretty difficult. Oops, not yet. Cool. And then once you're talking about streaming, and we talked about pivoting and aggregations and stuff like that, what if you have end users, right? Now you have a engine that has to provide streaming updates and potentially have streaming aggregations where each one of your users is maybe grouping by different things. Each one of your users is applying different filters. It obviously can get pretty complicated pretty quickly. And same deal, like a new user joins. What view of the world do they see? Do they get a snapshot of state, and then you provide them incremental updates? Again, for most frameworks and UI tools, like you have to do all this work. You have to provide that snapshot, know that they're a new user, et cetera, et cetera. So we wrote this library, me and several other people, called Perspective. It's on GitHub. It looks like this, Perspective. We wrote it at a bank for bank use cases. And the kind of tagline is interactive analytics and data visualization component, which is especially well suited for large and or streaming data sets. Now, it's not tailor-made for like big data or anything like that, but it is very good for medium, small to medium-sized data sets that might stream. They can be static as well. And the key thing there is that interactivity of it, right? So everything that I show you, I'll try and show you 4 different views of the same data. And that interactivity is all going to be powered by Perspective. So homepage, this is all linked from the slides, but this is basically the GitHub page. There's a link to the homepage here. You can find lots of examples, which I'm going to go through in just a second. So concretely, what this means is that Perspective itself is a streaming pivoting data engine. So you load data into it. You can think of it kind of like a database, but it's not really a database. It's written in C++. It's bound to Python on the back end. So we just have like PyBind bindings. And on the front end, it's bound into JavaScript via WebAssembly. So we compile the same C++ code in the back end and for the front end. And it has the same version of both. And then there are UI plugins. So it's a data component. But when we want to manifest that data with different visualizations, there are plugins which are written in a combination of Rust and TypeScript. And I'll show you a bunch of the different UI plugins in a second. So one of the cool things is that like the back end and the front end are both the same code. So it lets you kind of have different architectures. You can use it just in a JavaScript kind of fully client-side way. You can have a Python web server with a JavaScript-based views. So the symmetric C++ engine basically means that when we're transferring data back and forth, we basically don't need the GIL for stuff because we don't really need to prep stuff on the back end. We can kind of send it as is the front end, and it's the same code running on the front end. The virtualization, so that was that wanting to have kind of unbounded grids. We send diffs back and forth via Apache Arrow. So we try and keep it as fast and get that data back and forth as quickly as we possibly can. So I'm not going to talk too much about the pure client architecture. It's quite cool. You can have just a web component, a one-liner in your HTML, and maybe one line of JavaScript. And you have this full component without any Python and potentially without any web server if you're just pulling static data. But I'm going to talk about the kind of client server having a little front end. It'll be a tiny amount of JavaScript, so nobody leave quite yet, and a little bit of Python code. And those front end, as I said, they're web components, which basically means they're custom HTML elements. So there's a perspective-viewer that you can use. The plugins provided are the table. Obviously, I'm going to talk a lot about grids, but a pretty powerful grid engine, but also charts, heat maps, bar charts, line charts, scatter plots, stuff like that. And maps come out of the box. You can also kind of write your own plugins. So if there's your own way you want to visualize things, it's a pretty extensible system. And one of the key elements here is that we kind of give the power back to the end user to explore their own data. So I'll show you the configuration of how do I want to pivot things. You can pre-configure it so that it loads up by some default. But as an end user, you can also interact with the UI to make new pivots or do sorting or even derived expressions and stuff like that, user-derived functions, whatever you want to call them. OK, so at this point, everyone stop believing me maybe. But I'll show some code. And it's available at this link as well. OK, so I'm going to start with some standalone examples from the website, just to kind of motivate further what can be done. Then I'll look at the Python side in a notebook. We have a Jupyter widget, which I'm going to use a old school Jupyter notebook because I just broke my Jupyter lab, as I said. And then I'll show taking that notebook and turning it into a web app. And hopefully, it's going to be a small enough amount of code that like everyone follows along and could reproduce it. If not, the code is posted on that link, so you can look at it there. Cool. So here we have a bunch of different examples, trying to do different things, show different types of data. Here's an example with just some like Olympics medals. So this is perspective running on the back end. It's doing some pivoting by sport, some splitting by age to produce this kind of aggregated view. And then the plugin that I'm using is the heat map plugin. So we can see group by age, split by sport. I said it backwards. There's a little bit of layout stuff here as well. So I can, for example, close this. And I think there's a second one there too. So same type of data, but organized in a different way, group by sport, order by name. And so all these interactions are purely happening on the front end. There's no user code that we need to worry about for these things. You can change these plugins. So I can turn this into a data grid. Oh, I disconnected it slightly, didn't I? Yep, there we go. So here's that same stuff as a grid. This is not a huge data set, so it's not a ton of data. But we see that same type of thing. We get some of these niceties that other grids have. So for example, I could do something like some spark bars, right? People like to see visually kind of these differences. Some other cool things you can do is because you have this kind of symmetric engine running everywhere, you can do things like cross-filtering. So I can say, if I have a collection of these tables, let's just keep the same one, but we'll show it in two different forms for now. Let's turn this into a grid. That's not a very interesting grid. Let's get rid of those group bys and split bys and just make it a flat grid. Oops, nope, no expression columns yet. No. All right, let's just throw all these other ones in. There is a whole expression engine, but that's going to be the subject of a later talk. Cool. So I can do things like cross-filtering, which is basically where you apply these same operations, in this case, like a filter operation, across all of your views. Right? So when I click on boxing, for example, it'll just cross-filter all the other perspective viewers on the page by that filter. Right? It would be like where sport equals boxing, something like that. So it's we tried to adopt a little bit of like a SQL-esque kind of syntax. I'll show some other examples. So this is just to get a sense of like what it looks like and the types of things you can build. Here's that maps viewer. I live in New York, so got to have a little bit of a New York shout out. But this is a visualization of the City Bike, which is like our bike rental service that we have. So hopefully it will load. You can see this is kind of like scatter overlaid on a map engine. Same deal here. And again, all that same cross-filtering could apply. So if we did like a pivot, this data set doesn't really have a good pivot, but we could kind of sub-filter down all the other views. One more, we got some themes. This is some movie like revenue data set. Same deal, you've got your cross-filtering here. So you can cross-filter by studio. This is kind of a heat map, I think, of the whatever it is. Oh, this has some expressions in it, which is kind of cool. So these are like user-defined functions. They're defined using a library called exprtk. And here we're just bucketing IMDb ratings and bucketing Rotten Tomatoes ratings and looking at a kind of heat map of those two. So lots of different things that you can do, lots of different visualizations that you can build. And all these things that I'm kind of doing here, you kind of allow your users to use as well. If they keep this little thing closed, they never have to edit anything, you can get rid of it. But if you want, you kind of provide your users this ability to have kind of a Tableau-esque experience. And it takes a little bit to understand some of these, how these things work, but it results in a very powerful kind of end user experience for data interactivity. Okay, so I'm going to do a demo now, some Python stuff. I'm going to use two libraries. One is called Superstore. I just needed a data generator library, so I wrote a little one. Also, Pandas deprecated the time series generation. So this just is going to generate some data for me. In particular, I made it generate some data about machines. So it's going to create a bunch of machines, give those machines a bunch of utilization, give them some role, some number of CPU cores, whatever. And then it'll randomly generate jobs that are running on those machines. And I'm also going to use a library called CSP, which is a Python stream processing library, which basically makes it very easy to think about data streams. It's a forward propagating graph that you can have things ticking and kind of pushing data around. These two are not terribly important for this talk, but that's just where the data is coming from. And again, this notebook and all the content here is available on the GitHub repo. So I'm just going to import perspective. We have a thing called perspective widget. I'm going to use that library to make some machines, that superstore library. So again, just kind of randomly generated ID, cores, region, zone, whatever. I wanted to have some nice things to pivot by. I can randomly generate, for example, some usage information. I can randomly generate like the status of that machine. It's got this much CPU used, this much memory free, whatever. And I can randomly generate some jobs, though I don't know, it depends on the machine what type of jobs it will create, so that might not return data right now. This little block of code, again, not particularly important that you know what it does, but basically I'm going to create 4 of these perspective widgets, and I'm going to use that CSP library to just generate data and push it into them, right? Again, stream processing in Python can be a little tricky. CSP makes it easy. I'm basically just saying calculate some machine usage, and then push all the machines into one of those widgets, push all that usage information into one of those widgets, push all that status information, et cetera. So not a ton of code, not particularly important. And then I instantiate my perspective widgets. I'm going to do some sorting pre-configured on the Python side. I'm going to have the settings be false, so they won't have those configuration views available. Create those things. They are somewhat statically typed. You can feed data into them, and they will try and expand, but your columns need to have one data type, similar to most data frame libraries. I'll do a tiny bit of layout using IPyWidgets. I'm just going to make a 2x2 grid of these things. So we can see, looks something like this in my notebook. I have to keep the font size pretty big, but you can see I've got 2 and 2. And then I'll just run CSP, and we'll get some data feeding into them. We'll see some stuff is updating here in real time, right? This is the machine utilization is updating every second or something like that. Right, we're generating some jobs randomly. All right, and these widgets are nice. Those same interactions that we can do on the front end. So, things like, changing a group by changing sorts, you're also able to do on the back end. So in this case, this is the status widget. And these things are going to oscillate between active and idle and stuff like that, kind of at random, based on what's running on them. So I'm just going to reconfigure them to be, in this case, a bar chart. I'm going to group by status. So I should basically see a bar chart of how many of my machines are active, how many are idle. And I'll change the columns a little bit, add some aggregations. All right, so now I've done that here, and a little bit easier to see things updating in real time. See the jobs, I think they update every 5 seconds or something like that. All right, so the takeaway from this is, if you're in a notebook to start, if you're never building a full-fledged web application, there's still a lot of good usage here. You don't need to be constantly typing in pandas or polars expressions to pivot things. You can kind of load it up and then interactively do things, and it is a widget, so it is reflective, right? So if you make changes via the widget, you can kind of interrogate the Python object and see what's happening there. But this is a talk about web applications, so we should probably talk about a web server. And it's basically the same code. So I have a little bit of code here to make a perspective app. To hook perspective into a web server, you basically need something to run perspective, right? Run the perspective manager. We have examples on the website. There's a link here. But they're also available from the perspective homepage. For Starlet, so Fast API, Starlet, that kind of ecosystem, Tornado, and AIO HTTP maybe. But the code isn't particularly interesting. It's basically something to bridge that gap between your web server's WebSocket and perspective, which wants to communicate across it. So basically instantiating one of these perspective Starlet handlers and plugging it into my app. And then I have a little bit of code here to just serve my index.html and the JavaScript assets. And then I put cores because I never know how to use cores, so I just threw it in there just in case if something wouldn't break. I've got the same code from my notebook. So again, using the CSP library, just making some of these ticking data streams and then plugging them into perspective, right? I have them ticking 1, 5, and 5 kind of second intervals. And then this kind of plugs it all together. I run host these tables. When I host a table on the web server, it'll be available from the front end. The front end itself is also super easy. I know I told you I wouldn't show you too much JavaScript, and it won't be too much JavaScript. But basically, I have these perspective viewer web components. I gave them some IDs so it would be easier to track them. And then I kind of connect to my web server, and I just load up the web server connection. So it's 1, 2, maybe 3 lines of substantive code. And then same deal, I can pre-configure some of that visual the plugin that I want to use. In this case, I want that status to look like my Jupyter notebook. I want it to be a bar chart. I want to have some aggregation, whatever. So I can run this. And it was broken earlier, but hopefully it'll work this time. And I can pop over here, and it should start ticking in real time. There we go. All right, so again, I have all that same interactivity here. I can reconfigure things. I did say high performance, though. So 5 seconds and 1 second isn't really high performance. So let's go and make that 0.1, 0.5, and 0.5. Let's run it again. Now it should look a little nicer. That's pretty good. But it's a demo, so let's make it 0.01, 0.05, and 0.05. And that should be really good. All right. And I should mention that there are other ways we can look at this data. So same thing is running. Here I just have a slightly more complicated view that I produced, where I'm going to have some, if I don't destroy my machine first, where I have some more. It's the same web server running both of these. But here I have some additional aggregations being done. I have a 3-layer group by kind, region, and zone. I have some Spark bars here happening in real time. This is my vanity page, right? No one's actually going to look at this. You can kind of get a sense for where these incremental changes that we made using Apache Arrow for diffs, being able to configure these things where it starts to pay off when you really scale up. All right. My computer's going to run out of battery, so let's hop back. So takeaways, basically, if you need to build kind of relatively high performance, obviously nobody's going to look at something that's ticking that quickly. You want to have some interactivity. You want to have this ability for end users to reconfigure things. You want to have streaming data. You want to pivot. You want to provide kind of different views on the data. Perspective is a great choice. It's Apache 2 licensed, open source. Lots of examples, though never enough documentation. And provides a Python widget in a notebook and a relatively easy to use kind of Python library that embeds with basically any of the popular web servers. Yeah, I think that's it.
Thank you, Tim. So there is no questions in Slido. There is a question live.
I did put my questions on Slido, but anyway, I'm going to read them. First question is, can the user configuration, basically the configuration that the user does in the browser, be saved to the server side?
Yeah,
for example,
so
in the user profile?
The configuration and the data here is separated. So all of the configuration is done via JSONs, basically. So it has this kind of save restore. I've typed it so many times, it's already there. Kind of save restore interface. I know this font is super small for people to read. That basically says, plugin datagrid plugin config. So all JSON based, so you can easily reload it, save it. As far as saving it to the server, it doesn't come out of the box, but it's basically just a JSON. So one of the first things that I write whenever I write a perspective app is I have a little drop down of basically do you want to save your layout? If you do, in the JavaScript, it's just save. That gives you back a promise to a JSON, and then you can store that. A lot of times I just store it in browser storage. There is a new version which has this client-server interface written in Rust, which is going to do some more of that, some more configurability from the Python side of the front-end component. But right now, the kind of client-server interface is almost exclusively data.
Okay, and second question was, how easy is it to integrate the front end with let's say, another existing framework in React or Vue.js that you...
Yeah, so that's the nice part about just having it be a web component. It's just a perspective viewer element. So once you've imported the library, you have a custom element that you can do whatever you want with, so it'll work with React or anything like that. You have to worry about sometimes React lifetime, so you want to give it a ref and make sure that you're not regenerating the web component excessively, but otherwise, I use it all the time from React.
Thank you.
Thank you for the talk. I would like to ask you about what are the limits that you have. You say that in terms of big data, it's actually get to medium-sized big data. Is it? I saw that there are used extensively by Arrow. So is it something actually that allowed using like a connection to Spark data frames and or data like in partitioned Parquet style column and dataset.
So there are two parts to this. I think if you have a flat grid, you can put as much data as you want in that. The interface is purely virtualized, so as you scroll, it will just load up the next chunk of data. Once you start to do aggregations, it slows down as it would naturally, because like if you have to do a column sum in a massive data set, you have to iterate through the data set. One of the nice things there is some subset of the aggregations can be done online. So once you've done a pivot, if you stream in additional data, a subset of the aggregations don't need to recalculate the whole column. They can just pull in the new data. The current version, the client-server interface is pretty internal to the library. So you could have just the JavaScript component and interact with whatever you want on the back end. That would work totally fine. But some aspect of that pagination, not pagination really, but it's kind of like pagination under the hood, you would have to implement yourself. In the next version, which there's a PR open for it, we make it a little bit easier for you to write your own client or server or whatever. So you can basically not have the perspective engine be used for the data storage. You could connect it to DuckDB or any other database or backend storage system. So it's basically exposing that interface as an end user implementable thing. Today though, data limitation wise, it tends to be several gigs that some of those aggregations start to break down. I still think it's beneficial to do. There's a number of things you can do as far as limiting the total size to make things quick, especially for streaming data. But if you have a massive data set and you just want to visualize that data set, I think there are probably better tools.
Okay, I have the question slide now. So, can you customize the tooltip of the graph?
The tooltip of the graph, I'm not sure if you can. That's a good question. You can choose which fields go in the tooltip, I think. But so it'll show the 3 pivots and then whatever you put into this tooltip. But I don't think you can customize it further other than by, for example, doing a computed column. Right? So if you do a computed column, I can say I'll probably type in something nonsense, but I could do CPU +1 or something like that. All right, now I have a derived column, which I could also put in that tooltip. So you can kind of see new column 1, and it was doing something dumb. It's just doing CPU +1. But outside of that, you can't configure too much about how the tooltip looks internally. That's not a us thing, really. That's these plugins use other libraries. So this uses, what is it, D3, FC D3, something like that. Uses a D3 kind of finance-oriented chart library. The grid is a separate grid plugin. The maps is one of the maps libraries. But if you did want something fully bespoke, you can always implement your own plugin.
Okay. And the last question. Can you point the backend to a Parquet file or a PyArrow dataset with multiple Parquet files and explore that data in the UI?
Yeah, so we have one example on here. I think it only does CSV. Oh, no, it says CSV or Arrow. That's good. Should review my own examples beforehand. And then I wrote a little wrapper as well, which I'm definitely not going to be able to find right now. It's called Perspective Parquet, Perspective-Parquet. It's on PyPy. If you go to that library, I don't remember exactly what it does, but I think what I did was I wrote a little plugin for Jupyter to just let you point at a Parquet file or something like that. But I think basically serving a Parquet file is as easy as read the Parquet file and call perspective whatever table dot update with the data.
Okay. Thank you, Tim.